Hello. In a previous video, I had demonstrated how to simulate a fair coin in MS Excel. In this particular video, I am going to show you how to simulate an unfair coin. So we will straight away head to the Excel worksheet and see how that can be done. Okay, so here we are going to simulate an unfair coin which has 70% probability of showing heads and 30% probability of showing tails. But before we do that, just a couple of points. I would recommend that you see the previous video, which is the part 1, so that some of the small tricks that I have used in this particular video will not have to be explained again in this part. So let us first look at what the rand between function does. So we learned the previous occasion that when we use rand between 1, 10, then the formula generates numbers from 1 to 10 with equal probabilities, meaning the probability of getting 1 is same as that of getting 2 and so on up to the value of 10. Now when we simulated a fair coin, we used this function rand between 0, 1, which again generates numbers zeros and ones, each with 50% probability of occurrence. Now in a fair coin, again you have two outcomes. One is heads and tails, and both are again having a likelihood of 50%. And this is the reason why it was easy for us to match the value 0 with heads and 1 with tails. But here we have a slight difficulty in terms of simulating an unfair coin. Here the probabilities of heads and tails are not 50%. It's 70% and 30%. So the question is it possible to use rand between function to simulate an unfair coin? Yes, the answer is it can be done. So let me explain how that is possible. What I've listed out here are numbers 1 to 10 which can be generated out of this rand between 1, 10 function. And we know that each of these numbers will have equal probabilities of showing up when we use rand between 1, 10. But then we say, okay, that's fine. But then the trick is that you tell the computer that if you happen to get a number from 1 to 7, then consider that you have got heads. But if you get 8, 9 or 10, then you consider that you have got tails. So despite the fact that the number generates these numbers 1 to 10 with uniform probability distribution, we have partitioned these numbers in such a manner that 70% of the outcomes will be assigned the symbol H and 30% of the outcomes will be assigned the symbol tails. So which means that to simulate an unfair coin which has 70% probability of getting heads and 30% probability of getting tails, we can use the following formula. We say that if rand between 1, 10 produces a value which is less than 8, then consider that you have got heads. Else, if you get any of the remaining numbers, which is 8, 9 and 10, you consider that you have got tails. Now let's execute this formula in this cell. Okay, so on this occasion we have got tails. Why is it that we have got tails? We have got tails because the rand between 1 comma 10 function should have produced 8, 9 or 10, any of the three numbers. Let's run this formula multiple times. Now you see you have got heads and tails. Wherever you have got heads, it means that rand between function would have generated numbers, any of the numbers from 1 to 7. Now as you can examine this particular column, you see that there are many more heads than tails. Although the number of occasions is very small here, the number of trials is very small, but by and large this kind of a function, if rand between 1 comma 10 less than 8, then heads, else tails, would generate far greater number of heads than tails. The reason being that this is a simulated coin, which is a biased coin, and it is biased towards heads. So it is natural that you are going to get more heads than tails. So now what we are going to do next is, just like as we did in part 1, we are going to do an experiment where we are going to toss this biased coin 1,000 times, and then we are going to see that out of the 1,000 coin tosses, how many yielded heads and how many yielded tails. Okay, so I have already done some groundwork here in terms of preparing the Excel sheet. So these are the probabilities of heads and tails, and this shows that we are going to have a total of 1,000 coin tosses. And so I have already created these two columns, toss and outcome, just as in the previous video, and these tosses are from 1 to 1,000, as you can see. And so now what we are going to do is we are going to fill up the outcome column. So here we type in equals rand, I'm sorry, the formula should be if rand between 1 comma 10 is less than 8, then you consider that you have got heads, else consider that you have got tails. All right. Okay, so let us copy and paste this particular formula in all the cells of this column. So for that we just go down here, just we type in something arbitrary. Let's go on to the top. Let us copy this formula with Control C, and then we go right up to the bottom of this column by Control Shift and down arrow, and then paste using Control V. So there you are. So this column has gotten all the outcomes. So the first outcome happens to be tails, and the 1,000th outcome again happens to be tails. So what we are now going to do is we are now going to count that out of these 1,000 coin tosses, how many heads are there and how many tails are there. Let us count the number of heads and tails in these two columns, and so we say number of heads and number of tails. So let's do the number of heads. So here we use the formula COUNTIF, and then we have to give the range, that is the range of the cells where the outcomes are present. So the range is $6 to with a colon $1005, because that's where the last entry is, and what we are looking for is h. Let's run this. Okay, so we have 705 heads in this particular experiment, which has 1000 coin tosses. Now how about finding the number of tails? So we simply do a trick. We copy this formula by Control C and Control V will paste this formula over here. Well, both the entries are same because we have essentially run the same formula in both the cells. So in this cell we just need to replace this heads with tails and then press enter, and then we get the number of tails. And as you can clearly see that the number of heads and tails will match up to the total number of tosses which has been performed in this experiment. Right. So again, as you can see that this is a biased coin which has 70% probability of getting heads, 30% probability of getting tails, and if you have done 1000 coin tosses, then theoretically speaking you will expect that there are 700 heads and 300 tails. But then when you are doing a simulation like this, meaning that you are pretending as if you are doing a real life experiment, you will very rarely get exactly 700 heads and 300 tails. But the fact that our numbers of heads are pretty close to 700 and number of tails are pretty close to 300, it tells us that our simulation is all right. Now let us generate a bar graph and then see how we can depict the data in a graphical format. Okay, since this is not a video to show how to draw a bar graph, I have actually done it well in advance, and as you can see that if I keep pressing the F9 key, the whole sheet will keep recalculating itself. So you can see that with each press of the F9 key the column is changing, and so therefore the number of heads and tails are also changing, but the total number of outcomes heads and tails are equal to 1000, which are the total number of tosses that we have done in this experiment, which means okay, this is all fine. And as you can see in the bar graph that the number of heads are far greater than the number of tails, and in each run of this experiment you will see that roughly the number of heads are about 70% and the number of tails are about 30%. So which means that everything about the simulation and the formula that you have used to simulate this unfair coin appears to be all right. Now before I end, just a small note. Was it necessary to use rand between 1, 10 only? The answer is no. You could have even used a function rand between 1, 100, but then in that case the condition that you give is that if the number generated is less than 71, then you consider that it is heads, and anything else will be considered as tails. So the key idea that I wanted to present in this particular video is that, well, rand between function will generate numbers with your given lower and upper limit with equal probability distribution or uniform probability distribution, but then it is up to us to draw the line and partition the set of numbers in such a manner that you get the desired probabilities of heads and tails. I will end this video with a question, something for you to think over. Okay, is there any other way other than rand between function to do such coin toss simulations? Think over, and goodbye.